Okay, here's the solutions for 6 and 7 that deal with Celsius and Fahrenheit. So you were given a formula in class where Fahrenheit equals 9/5 times Celsius plus 32. Well, we're going to change that a little bit because they're actually talking about what will happen with the Celsius. So we're going to take the Celsius formula, which equals 5/9 times Fahrenheit minus 32. It's the same equation, I just am solving for Celsius because that's what we're talking about. Now, in this particular problem, we have two variables. They don't give us any of the information, so we can't really solve it yet. So what we have to do is kind of change our mindset. We have to think of at what point would Celsius and Fahrenheit be the same and deal with our problem from that perspective. It's kind of like if you and your friend have some money in your pocket and you want twice what your friend has, you would simply take your friend's amount, which you could say that you had, and then double it. So we need to find a point where Celsius and Fahrenheit can be considered the same. So all I'm going to do is I'm going to take that C right here, and I'm going to say Fahrenheit's going to be that same amount. So I can replace the C with an F. So now my formula will look like this. And again, remember, we're just thinking of Celsius and Fahrenheit starting out at the same number. So now I only have F in my problem. Now, the particular word problem says at what temperature will the Celsius reading be twice as high? So again, remember, I simply switched C to F. So this still was my Fahrenheit part. I want my Celsius to be twice as much. Remember, we switched F from the C. So now I'm going to take and double that because our problem says at what point will Celsius be twice as high? Twice as high means I multiply by 2. So now we have an equation. Whoops, I need a smaller one. Now we have an equation that I can solve for F. Just remember, like in our problem where we talked about two people having money and you want twice as much, you're going to need to double your answer to get what the Celsius degrees would be. I know it sounds difficult, but let's just work it through. We have a fraction in front of parentheses. So that's just like a fraction in front of variables. To get rid of that fraction, we're going to multiply by the reciprocal, which is 9/5. And we're going to do the same thing on this side. So now our 5/9 and our 9/5 cancel. So over here, we have top times top. So that's 18F over 5. And that equals Fahrenheit minus 32. Well, we still have a problem because we have a fraction. We have a 5 as the denominator. So we've learned in class that if I multiply by that denominator on both sides, I can cancel it out. So 5 divided by 5 is 1, and then 1 times the 18F is 18F. Then this side, I simply do the distributive property. So I'm going to have 5F minus 160. So we're going to go ahead now and do same change opposite. Now I have to solve for F, so you notice I have F on both sides. So I need to move the F from the right to the left. So I'm going to take a negative 5F, negative 5F. So now I'm just solving for F like we've done in class. So that's going to leave me 13F equals negative 160. Now I'm going to divide by 13, divide by 13. So my Fahrenheit amount is going to be negative 160 thirteenths. Okay, well that's really not the answer yet. We know that we need our Celsius to be twice that. So I'm going to take my negative 160, which is the Fahrenheit, F, and I'm going to multiply that by 2, or 2 over 1. So in reality, I have negative 320 over 13. And now since we're talking about a real-life measurement of degrees, we need to make a mixed number out of this right here. So we know our answer is negative. So 13 goes into 320. It's going to go in there twice. That's 26 with the 6 left over. Bring down the 0. It's going to go in there 4 times. That's 40, 52 with an 8 left over. And then we're simply going to take that 8 and put it above the 13. So now our Celsius, when it's twice Fahrenheit, would be negative 24 and 8/13 degrees. Again, that's because that is double what this is. This would have been 12 and 4/13. So now let's do that same thing on number 7. Okay, we know that we have the Fahrenheit formula, okay, is 9/5 Fahrenheit or Celsius plus 32. but we changed it to deal with Celsius. So Celsius equals 5/9 times Fahrenheit minus 32. Okay, in this equation it says at what temperature will degrees Fahrenheit be twice the Celsius? So in this one, we're going to take and change again Celsius to Fahrenheit because we're starting out even and we need to have only one variable. And we still have our 5/9 times Fahrenheit minus 32. But now we want our Fahrenheit side to be twice that. Remember, this is our Fahrenheit side. So we're going to take that and double it. So all of this gets multiplied by 2. And I'm using brackets instead of parentheses because I already have parentheses here. Okay, so we have Fahrenheit's going to equal, and now I simply do distributive property. Okay, so I'm going to multiply the 2 times the 5/9, and since everything's hooked together, I don't do 2 times Fahrenheit and 2 times the 32 because they're all hooked together, so you only multiply once there, kind of like this. If I have 4 times 13x, I multiply the 4 times the 13 to get 52. I also don't multiply the 4 times the x, do I? I just multiply by one part of that. Okay, so 2 times 5/9 is going to be 10/9, and then I have Fahrenheit minus 32 left over. Okay, so now let's solve for Fahrenheit. So again, I have 10/9. I'm going to get rid of it by multiplying by the reciprocal, 9/10. I could do that on both sides. So 10/9 and 9/10 cancel. So I'm left with 9F over 10 equals Fahrenheit minus 32. So just like the other problem, I have a 10 in the denominator. So let's get rid of it by multiplying both sides by 10. 10 divided by 10 is 1. 1 times the 9F is 9F. And then do your distributive property here. 10 times F is 10F. Minus 10 times 32 is 320. Okay, let's make our same change opposite switch. Okay, I do have 10F and 9F, so I'm going to need to move the 10F over by doing a negative 10F. So I'm going to be left with negative 1F equals negative 320. Now remember, we can't have a negative variable. So in that case, we're just going to switch it. So Fahrenheit would be equal to 320 degrees.